Now, algebra people, people have had good questions covering the exponential values and the scientific notation with these problems. With this problem right here, this is number 6, the shrimp one. You've got to remember when you're working with scientific notation, and that's what these types of problems, 2 point whatever times 10 to the whatever power, 5.24 times 10 to the whatever power, anything where it's times 10 to a power, this is scientific notation. Now you've got to look at what you're doing with it. If it's multiplication, you multiply the numbers out front, okay? You multiply these two, 2.6 times 2.0. Now, somebody brought up, okay, so when you have this, when you take something to the powers and you're multiplying the exponential values, these are the same. This doesn't, it could be x, it could be n, it could be anything it wants to be right in here. The 10 is just because it's scientific notation. You are supposed to add the exponential value if it's multiplication. So this would be a -3 plus 11. Now somebody said that -3 plus 11 and 11 plus a -3 are two very different answers. Then they sent back another email and, oh gosh, forget that. They caught themselves. -11 plus, or -3 plus 11 and 11 plus -3, exactly the same answer. Don't think of it as a plus problem. Think of it as a -3 and a positive 11, or a positive 11 and a -3. Forget the plus signs. You've got a -3 and a positive 11. You combine the terms. That means you've got a subtraction problem. Both of them are going to equal 8 regardless of which way they're written, okay? Be very careful with that. They're both a positive 11. They're both a -3. They both would equal 8. So that part of the problem is not a big deal. But some of you are coming back and going, okay, that other one, 2.7 times 10 to the blah, 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 divided by 3 times 10 to the blah, blah, blah. Division is the same thing. You look at the numbers out in front and you just divide. Just divide 2.7 by 3. With the exponential value, since it's division, since multiplication was add, what do you think division is? Correct. It's going to be subtract. So don't freak out. Divide the big numbers, add or subtract the little. I've done this video for these specific problems multiple times. Multiple. Now, when you start getting down to these later problems in this work, like way later, when you're starting to work with geometric sequencing, like numbers 13 and 14, do not get freaked out by geometric sequencing, okay? Geometric sequencing has a formula that you need to follow. I'm going to write the formula, okay? The formula for geometric sequences. Geometric sequence formula, A sub n is equal to A sub 1 times the quantity of r to the n minus 1. Okay, what is all this stuff? A sub 1 is just your first term in your sequence, okay? The r is the rate of change, or the ratio for the problem. Now, what that means is it's a common rate of change. If I have a group of numbers, let's say like 3, 6, 12, 24, and you look at this, what is happening? What is the change? Some of you would go, oh, from 3 to 6 is 3, from 6 to, it's 6, from here to here it's 12. There's a short method that you can take. All you do is take a term and subtract the term before, or divide by the term before it. 24 divided by 12 is equal to 2. Is it the same all the way through this? 12 divided by 6 equals 2. 6 divided by 3 equals 2. So the common rate of change, the common ratio is 2. You're multiplying by 2 all the way through here. So your common change, your rate, would be 2. Now, A sub 1 is the first term in the sequence. So here, what's your first term in the sequence that we're working with? It's a 3. Okay, but what is n? N is the nth term that you're working with. So if I said, let's find the 10th term, the nth term, n is equal to where we want to find the 10th term, I'd put a 10 in for where they want to work to. 10 minus 1, okay? So to find out what the 10th term of this, now you could sit here and go, 2 times 3 is 6, times 2 is 12, times 2 is 24, times 2 is 48, times 2 is 96. You could do that, but it's going to get to be a bit of a pain in the butt to the 10th term. This formula up here is going to make it, so if you're given the first term, if you're given the rate that it's changed, or you can find the rate that it's going to change by, and you're given the term that you're supposed to work towards, you can do all of this work. So let's look at number 13. What is the 11th term of this geometric sequence? Okay, the 11th term of that geometric sequence. I'm going to work on the paper here and have our information. We know that according to what we were just given, A is the first term. Now, let's see what their terms are for this one. The geometric sequence, 4, 12, 36. 4, 12, 36, and so on. They want us to find the 11th term. Well, we know A to the 11th is what we're trying to find, is equal to, what is the first term in our sequence? They tell us what the first term is. It's 4 times R, what is the rate of change? We'll just do the rate backwards. 36 divided by 12, that equals 3. Take 12 divided by the number of 4, that equals 3. So your common rate of change, your ratio, is multiplying by 3 to the nth minus 1. Well, what is the term that they wanted us to find? The 11th term. So it'd be 11. Can you mental math that? What is 11 minus 1? Done. 10. Now you can use a calculator to do this, so you don't have to do 3 times 10, or 3 to the 10th power, 3 times 3 times 3 times 3 times 3. You can use a calculator to do that crap, and then multiply it by 4, and that will give you the value of the 11th term in this sequence. The formula, a sub n, a whatever the nth power is equal to a sub 1 times the quantity of the rate to the n minus 1. Remember that. Now, how will that help you with number 14? Write an equation for the nth term of the geometric sequence. They give you the first term. Okay. In number 14, they give you the first term, negative 18. A sub n, because we don't know what term. It's the nth term. It's for whatever it goes to. But we know the first term is negative 18. Do we know the rate? Negative 18, negative 6, negative 2. Okay, take the term over here, negative 2 over negative 6. Negative, negative, cancel out each other out. 2 and 3 turns into 1/3. Take the next one, 18 and 6. 6 and 18. Now, it's a negative and negative. That cancels out. 6 and 18 reduced to 1/3. That's our common rate. 1/3 n to the n minus 1 power. Because we don't know what term, all we need to find out then in this problem to be able to do it is what the crap term is that they want us to go to, and change the n into the term that they want us to utilize. So the formula for this is a sub n, a nth power, is equal to a sub 1 times the quantity of your rate of change, r, to the n minus 1. This will work for all geometric sequences. All geometric sequences. So don't freak out with that. Good luck. I will talk to you later.